Okay, so we're going to get started. I know there are printing issues for these, so if yours didn't come out of the printer yet, it's okay. Right? We'll give it another shot. I was just over there resurrecting the printer. It's a terrible printer. It just is. It's worse than the one that's broken. So, you know, it is what it is. Anyway, hopefully by the end of the day we can get all of them out, and I'll try to keep babysitting it and see if we can get it to spit stuff out. Again, these are my paper records just in case something were to happen. I have paper records. I will grade your online posts. And I also, if you don't have the paper version in, I don't mark the paper version late. So it's just the online one that matters. That has to be turned in. As long as that's posted, I'm happy, and we're all good. So today we're going to start with exercise 212, which is the next iteration of this topography that we've been working on. This one is a little bit more involved, and I'll take you through about half of what we have to do. And then next class we'll do the second half of what we're doing. But each day, as I said, I'm going to start from the very beginning. So the repetition is good for you. So I'm going to start as if I've never done this before at all, even though it's a repetition of what we did last class. So I have a few things that I'm going to use as reference a little bit later on. But as I start to get this set up, the first thing that I need to do is pick my terrain. And if you want to work with the terrain that you worked with last class, that's OK. If you didn't like that terrain or it didn't turn out the way you wanted it to, and you want to pick something different, by all means, now's your opportunity to change. After today, you probably aren't going to want to change because you will be down the road and doing work. So today's your day to change if you want to change. I'm going to go ahead and pull up SketchUp 2017. In the interest of going through all the steps, I'm going to go through it. I probably won't take quite as long to do this. You don't need me to talk for the full 3 hours. We'll try to limit my talking a little bit so you have some time to work. I am going to work with the architectural design feet and inches template in SketchUp. And then I'll click on Start using SketchUp. And then I need to go get my terrain itself. We'll let SketchUp finish up its load here. It's going to give me a few errors, I think. There we go. And I'll go ahead and get rid of the person. I don't need the person. I'll press the delete key there. And I'll go to File, Geolocation, Add Location. And I'll pick something. And so last time I did Mount Diablo, I don't know, let's go to Hawaii today. Why not? Remember, I keep zooming in until I get that box. That's going to be what the maximum amount that I can capture. I'll go ahead and click on Select Region. That's the maximum amount I can capture. I'll go ahead and grab it. And I want to make sure that this one looks OK, because I really picked it completely at random. I have no idea if this is going to look OK. Let me go to Geolocation, Show Terrain, and that's terrible. So we're not going to do that one. Let me, you know what, I already have a Hawaii example, so I'll use that example as part of today's, instead of going and trying to find something else. But anyway, you can spend a little bit more time working on that. Once you're done, you'll save it as a SketchUp 2013 file. And then you go ahead and move over into Rhino, and we'll open up the file in Rhino here. I'm going to create a new large object that's in inches as my default unit. And we'll let Rhino update. There we go, Rhino. All right, so now that that's loaded, I'll go to File and then Import. Remember, this time I'm importing. I'm not inserting a block reference. This is actually the geometry. I'll go to File and then Import. And I'm going to drop in that Hawaii example that I just saved. And I think it's in 211. There you go. And I'll go ahead and say OK. The SketchUp options, I want it to come in as a mesh. And the rest of these default options are just fine. I'll go ahead and click on the OK button, and that will bring in. Looks like I inadvertently brought the little person in here. And there's the terrain itself. So this is a pretty good one for you guys to see, because there's lots of valleys in it as part of what I'm doing here. I don't need the flat piece of geometry, so I can go ahead and press the delete key to get rid of that flat piece of geometry. I'm also going to go over and organize my layers a bit. So I'll create a new layer called SketchUp. And I'm going to move the Google Earth Terrain, Layer 0, and Google Earth Snapshot all to the SketchUp layer. There we go. And now that they're all on the SketchUp layer, I have the ability to turn all of the Google stuff on and off. So that's perfect. I'll leave it named SketchUp. Next thing that I need to do is I need to convert this geometry into a NURBS surface. So this is repetition of exactly what we were doing last class. So I'm going to run my contours in the x direction, I'll run my contours in the y direction, and I'll create a curved network surface out of that. So let me create a couple layers here. Layer 2 we'll call contour x. And layer 3 we'll call contour y. And really, contour x and contour y are completely arbitrary. I could do them in either direction. The point is, it's one in one direction, one in the other direction. So let's make contour x active here. I will go ahead and type the contour command. It's also available under curve, curve from objects, and then contour. And it's going to ask me to select the object for the contour. It's the surface here, the mesh. I'll hit enter. Contour base point is going to be down at this corner. If I can't snap to that point, I need to turn on vertex snap. There we go. Now I'll be able to snap to that point. Direction perpendicular to the contour planes. Remember, I want to be off here in space with no smart tracking or anything. It's just off along the x-axis. If you're struggling to get this, make sure that ortho is turned on, which it is for me. And we'll go ahead and go off in this x direction there. Distance between the contours is going to be 100 feet in my case. So 100 followed by an apostrophe, and then I'll go ahead and hit enter. And that then creates all of my contours. Remember, before I do the contour in the y direction, I want to deselect everything so that nothing's selected. I'll double click on contour y to make it the active layer, and then I'll repeat the contour command, which is again curve, curve from objects, and then contour. Select objects for contours. It's going to be this surface. I'll hit enter again on that point, and we're going to go off in the y direction this time. Distance between the contours, 100 feet or 1,200 inches. And there we go. At this point, I can turn off the SketchUp file altogether, and I have just the wires that represent my terrain, just the contours. So we need to do a little cleanup before I create the actual final version, and I'll do that in the top view. And we'll get rid of a little bit of this, so we'll say there, there. Yeah, something like that. You know what? Let me take that one instead. There we go. I'll type trim after I've selected those. Notice that I selected the objects that are going to perform the cutting in this. And then I can go ahead and drag some lines through to create this trim. And there you go. It's nice and clean now. If I had trouble doing the network surface, chances are the trim didn't complete correctly, or one of my contours wasn't perfectly aligned. It was off on an angle, in which case if I looked down at this, it wouldn't look like a perfect grid, which obviously it looks like a perfect grid, so everything turned out OK. So at this point, I have a nice contained set of curves here, and I can go ahead and do the network surface or the curved network to create the surface for this object. Before I do it, though, I want to go ahead and save my file. So I'll go to File and Save, and we'll put it into today's folder. This is fall of 2017. Here we go. And I'll go ahead and click on Save. There we go. So I have that file saved. Now I need to make up my terrain. So I'll rename layer 6 here to be terrain. We'll make it the active layer. And then I'll go ahead and select all of those curves and go to Surface, Curve Network, or type in Network Surface is the command. Network SRF is the command for typing it in. It's saying, guess what? There's a lot of curves here. Are you sure you want to do it? Yes, I'm OK. Good. It recognized A, B, C, and D. Those are the 4 sides. Perfect. The rest of these default values are just fine, and I'll go ahead and say OK. There you go. When it's done, it creates that big dark object. I'll click off so that nothing is selected, and then I'll click back on to select just the surface. Turns that bright yellow because of the density. And then I'll use the rebuild command. So I'll type rebuild. It's also available under the edit menu. You can go to edit and then rebuild. And I'll rebuild this at 100 by 100, which was about the sweet spot last time. I'll start with that as well. I'll go ahead and say OK. And there we go. It's smoothed it out a little bit for me. I'll go ahead and turn off contour X and contour Y, and I'm left with this terrain. If I wanted to smooth it out a little bit more, I could do it again, but this seems reasonable for what I'm ultimately going to do. OK, so what was that? 12 or 13 minutes. That was essentially what I did in an hour last class. So you see, I compressed that hour down into the 12 or 13 minutes. But you guys already did it once, so hopefully it'll be a little bit easier. Like I said, I'll do this whole thing one more time next class so you see the whole process all the way through, but I'll continue to speed up the various parts. So here we are. I have my terrain, and last class we did it a little bit more. We did some more contours, and we exported an AutoCAD file and whatever. We're not going to jump to that place just yet. We're going to start thinking of this as an actual physical model that we want to build. And so the size of this physical model could be as big as we wanted it to be. I'm deliberately sizing it at 11 by 17 because it's a convenient size to cut on the laser cutter here. So the bed of the laser cutter, and a lot of you guys have already laser cut, so this is old news for you, is 12 by 24. So that's the maximum size sheet that we can fit. So 11 by 17 fits rather nicely in that 12 by 24. It's unlikely that you can actually cut a full 12 by 24 without doing some manual cutting. So don't ever think that, oh, I could just make a 12 by 24 and glue them together or something. You need to have something a little bit smaller. I'd leave at least 1/4 of an inch around the outside of that 12 by 24. So you're really more at 11.5 by 23.5 as the maximum size that you can cut on the laser cutter. So what we need to do is, if we envision this as a model, we need to make it 11 by 17. And so we have to start thinking through scales and how do scales work and how are we going to build this at a particular size, etc. So we're doing this a little bit backwards in this class because I'm saying, guess what? You're going to do it at 11 by 17. That's the final model size, not you need to do it at 1 to 200 scale or some specific scale. And a lot of times in studio, you guys are in 220 right now, a lot of you, and Anthony would give you, oh, you need to build this model at 1 to 200, or 1/4 inch equals a foot, or 1/8 inch equals a foot, or something like that. So the scale would be given to you. In our case, I'm not giving you a scale. I'm going to let you determine the scale by the size of the model. And so in order to do all of this, we're going to bring up a little cheat sheet. And I have this printed out on the bottom of your exercise here. It's available online. It's available in the book. This is your cheat sheet. And this will save your life because you don't actually have to do any calculations. You just have to pick your scale and make sure you do it correctly. So first off, I need to understand what scale I want. And I've got a variety of scales up here. Generally, they're from smallest to largest, or excuse me, largest to smallest scales. So, well, I don't know which way you describe it. Anyway, I start at 1 to 500 feet, which means that your 11 by 17 size right here is 8,500 feet by 5,500 feet. So we're thinking like about a mile by a mile and a half in its size. That's the terrain that you're building. Obviously that's really big, and it would be on the scale of like a city or something that you'd be modeling. If we come down here into more of the architectural size, like 1/4 inch equals a foot, if I come over here, we'd be looking at a 11 by 17 size of 44 feet by 68 feet. So at 1/4 inch equals a foot, that's obviously, it's a bigger model. So you might be more on the building size or something. There may be a happy medium in here, 1/8 inch equals a foot at 88 by 136. You know, just thinking about what you're modeling, the scale is going to be somewhat appropriate. For what we're doing, if we do a big scale, that's fine. It doesn't matter. I'm guessing that my scale is going to be somewhere in here, maybe 1 to 200-ish, which would be 2,200 by 3,400 feet-ish. And that's going to fit nicely on my piece of terrain. So what I'll do is I'll take note of, and I'm going to give it a shot at 1 to 200, and I'll take note of this size, 2,200 feet and 3,400 feet. So those two values. If I could, I would highlight it or circle it. For you guys, you can circle it on the sheet or highlight it and whatever. Don't do it yet because you have to decide which one is right for your terrain. But once you figure it out, you'll highlight this row because it'll make sense. So let me come back to it in just a second. So at this point, I'm going to go out of the perspective view. I'm going to go into the top view. There's my surface. And I'm going to move down to layer 7. And I'll double click, and maybe I'll rename this to be model for lack of something better. So I have something called model, and now I'm going to create a rectangle that is the size of the 11 by 17 at a specific scale. So I just looked it up on here. So I'm at 2,200 feet by 3,400 feet. Right there, 1 to 200, 2,200 feet by 3,400 feet. So when I create my rectangle, I'm going to say at 3,400 feet, comma, 2,200 feet, and I'll hit enter. That gives me a rectangle. So this rectangle, if my model was at 1 to 200 scale, right, would be this size. Now I could go back and I could look at some of the other scales that were available there as well. So instead of the 1 to 200, I could do the 1 to 250. Which would be 2750 by 4250. So I could say at 2750 feet, comma, 4250 feet. Wasn't that it? Hold on a second. 2750, 4250. OK, good. And I'll go ahead and hit enter. And there's that size. And so I could then move this over the site. OK, that one fits too, so I could do that size. I could do, well, I could try that last, the biggest scale. So that was, I think, 5,500 by 8,500, wasn't it? 8,500 by 5,500. So this one would be at 8,500 feet, comma, 5,500 feet. Enter. There it is. OK, well, that one's a little bit too big. So I can't really do a 1 to 500 scale model because it's just too much. So the 1 to 500's out. The other two options are perfectly fine. I could pick either one. And so I'll do the bigger one for right now. It'll show more of the terrain. And I'll do this one. It doesn't matter whether you're in landscape orientation or portrait. It ultimately makes no difference. But sometimes you want to think about how this is, fits into your particular model. And so sometimes seeing it as a shaded mode, you can kind of look down on it. You can kind of figure out what piece of this model do I want. Maybe you have to do a little bit of moving. So let me go ahead and move this one over just a little bit like that. Now I'm getting more of that steeper valley, which is going to be harder to do, but it could be interesting. Well, yeah, something like that. We'll give it a shot. Once I've decided on that, I'll go back to my top view, and I'm going to project this square onto my terrain. So I'll type project. It's also under curve from objects, project. I'll hit enter. Sorry, select surfaces. There's my surface. I'll hit enter, and it'll project that rectangle down onto my terrain itself. So there it is on the terrain itself, which is actually kind of a nice piece of terrain. I like it. If I didn't like it, of course, I could move around and I could get a different piece of the terrain. So there it is in its form. That is ultimately the size that scales down to the 11 by 17 model that I'm going to be creating. So now it's a matter of trimming off all that surface that I don't need anymore. So I'll go ahead with that selected. Actually, I'll make nothing selected. I'll type trim, select cutting objects. It's going to be that curving space right there, that one, that curving line. I'll hit enter, and then I'll go ahead and trim off the rest of this terrain. So I'm left with only that piece of the terrain, which is what I want. You could split it instead if you wanted to. And so now I'm going to work with this little piece of terrain that's set up for the final model that I'm making. Does that make sense so far, how I got to that particular size? Okay, good. So now that I'm at that size, I need to think about how am I actually going to physically make this particular model. And so at this point, I need to go figure out what material I'm going to make this model out of. And so I'm suggesting for you guys for this class that everybody use the basic cardboard that's available in the bookstore. And I did go there last week and confirm that they have a big stack of cardboard. So that's good. Sometimes they run out. Hopefully they won't. Generally speaking, it's going to take you probably 2 sheets to do it. 2 of the sheets at the bookstore equate to 4 sheets individually on the laser cutter. Some of you will be able to do it in 3 sheets. It just depends on the complexity of your terrain. 3 of the laser cutter bed sheets. So now that I know that I want to make it out of that particular material, I need to know the thickness of that particular material. And you need to measure it really carefully. Because if you don't measure it carefully, it's not going to stack up correctly. So in the case of that cardboard, assuming that you use that cardboard, I happen to know that it's 5/32 of an inch thick. I've measured it. So I can give that to you. If you use that cardboard, it's 5/32 of an inch thick. If you used a different material, let's say you used chip ply, 4-ply chipboard or something, that might be like 1/8 of an inch thick, or it might be a different thickness. So you have to know what that thickness is. Okay, so that measurement is absolutely critical. For our case, it's 5/32 of an inch, and this contour material thickness, this is the column that I now care about. The rest of the columns I don't care about. So assuming that you're doing the cardboard, which I'm guessing you are, 5/32 of an inch at my 1:250 scale, which is the scale that I picked. I bring this over here. It's 39.063 feet. Okay, so it's really important that this value is in feet. And that represents then what 1 step in my model is equivalent to. So I know the thickness of my material, that's going to be 1 step. So I need to know what the distance is at my desired scale. So in this case, that 5/32 of an inch that I'm going to glue together equates to 39.063 feet. Every time I make one of those steps in the model, it's 39.063 feet. If you picked a different thickness or you picked a different scale, it would be a different value. Maybe 31.25. Maybe it would be down here if we picked, I don't know, 1/8 of an inch equals a foot. You'd be down here at I don't know, I'm probably off here, 0.125 or 1.25 feet. So it's going to vary. So for my particular example, 39.063 is what the correct one is. So I would circle that or highlight it or somehow designate that yes, this is the piece that I'm interested in. So now when I come back to this, I'm going to create a new set of lines, and I don't know, we'll call this contour Z. I'll double click to make that my active piece here. That's contour Z, and I'm going to slice this particular piece up as contour Z. So we'll go ahead and go to edit, or excuse me, curve from objects, contour, or I'll type contour. I'm going to pick this object. I'll pick this corner right there at the end. I need to make sure that I'm going straight up in the Z direction, not snapping to anything. There I am going straight up. And here, under distance between contours, this is that 39.063 feet. The foot sign is really important. There will be people who will just do it as inches, and it's not the right value. You have way too many contours. Okay? So 39.063 feet, and I'll go ahead and hit enter, and this will then slice my particular model up into all the individual little contours that it'll take to make this model. So I can look at this now as a bunch of stacks, so to speak, of pieces of cardboard. So let me go ahead and turn off my terrain. And I could actually turn off my model, and I'm left with all of those little pieces. We can confirm that it was done correctly by looking at it in the side view, and they should all be perfectly horizontal lines. That's what we're looking for. So now that I have this established, I could, of course, if I were making this, cut each one out and stack up a bunch of pieces of cardboard together and glue them together. And it would make this nice solid brick that would be really heavy. But it would also take tons and tons and tons of cardboard, and it would probably cost you $50 to make this model as you were cutting out all the pieces. So certainly you could laser cut it. It wouldn't be that hard, and you could glue it together. I don't want you to have to spend that kind of money. We need to shorten the number of sheets that are needed, save you the money. But in order to do that, we actually have to create sides for this model. So we have to create little steps that allow us to create basically something to hold the steps. So the next piece of this is to actually create the steps. So I'll go ahead and create a new layer, and this is going to be sides. And you could do side 1, side 2, side 3, side 4. It's up to you. I'll just call it sides. I'll make that the active layer. And I'm also going to change the color of that to be red so that I can distinguish it as I'm starting to model this particular side. So with the sides layer active, I need to go ahead and start to create these steps. And there's really two different methods for creating these steps, and I'm going to show you both. There's a method that I would prefer that you learn because I think it will help you a lot later on, but there's also a method that's a little bit easier to grasp initially. So I'm going to do both for you right now as you start to create this, this process. By the way, everything that I've been going through is available here under this Physical Modeling 6.1. It'll talk through all of the stuff and give you basically videos and there's me assembling. Actually, this video of me assembling is pretty funny. The glue that I use explodes on me halfway through, and I get glue everywhere. So it happens, right? Anyway, so those are all there. You can go back through and see the stuff that I'm doing, but of course I'm doing it for you right now live too. Anyway, so the first method of doing this, and actually, you know what? Let me call this sides 01 or sides method 1. And to do sides method 1, I'll do this end, I think. What I'll do is I'm going to come up here to the point tool. It's right here. But I don't want a single point because I have to repeat. I want multiple points. So I'm going to right click instead of left click, and it's going to give me lots of points. And essentially what I'm going to do is I'm going to go through and I'm going to stick a point on every one of the ends. And assuming that I have endpoint snap on, it should go rather quickly. Like that. And I'll go ahead and hit enter to finish. So I have all of those little points that are conveniently on the edge there. And if I were to take those points, and I could select them by drawing a box around them. The problem is if I drag a box, I'm going to get those lines too. I'm going to use SELPT for select points to just select the points because those are the only points that are there. And then I need to rotate them flat so that they're on the ground. And so I'll pick the low point, maybe it's that one here, and I'll do a rotate 3D. I'll snap to that point. I want to go off in the X direction, again, not snapping to anything. And we're going to go from straight up. Oh, come on. There it is, straight up. And we'll fold that over so that they're lying flat. Now that they're lying flat, I can start to work through and create my steps. And the only challenge here is that I have to be consistent. If I go from a given point, if I go down to the next point, and I have perpendicular snap on, I can work my way through. There's that. There's that. There's perpendicular. OK, so now wait a minute. I got to this point here, and this next point is straight across. Well, I actually have to go down one more time and then over and back up because it's the bottom of a valley. So in this case, I need to know what my value was, which was 39.063 feet. There it is going down. We'll go straight across until we match up with this point there. Perpendicular, and then we'll start working my way back up this side. I know this is not the most exciting thing for you to watch, but bear with me while I get through it. Okay, now I got to the top going across. So I end on the step. So in this case, I can go straight across, and then I'm going to start to go back down at this point. You can see why I made this layer red so that it doesn't confuse with all the other stuff that's going on. Okay, one more time. This is the bottom of the valley, 39.063 feet. Straight over. And we're just going to end right at that point, which was my last line. So now I'll take all of those points, so SELPT, select point, plus the line, and I'm going to rotate them back. I rotated right around that point, so I'll rotate 3D again, if I can type. Rotate 3D, there, there, and now I'll fold it back up straight like that. If I did it correctly, all of those little steps will line up nicely with the ends of my curve. You guys see how that worked? So by using the points and then rotating them flat, it's generally easier to draw your particular points. That's the easy way of doing it. The harder way is to use something called a seaplane, which is a drawing plane. And this is the more advanced way of doing it, but if you learn and kind of internalize how seaplanes work, it'll benefit you down the road. Because you can suddenly say, oh, I need to draw on this wall. Let me change my seaplane to be on this wall, and I can draw on the wall. And then I can switch to some other wall, and I can draw on that wall. So it's a little bit different. It's kind of like the UCS system, the Universal Coordinate System in AutoCAD, if you've ever messed with that. Most people don't, because AutoCAD is really chunky in 3D anyway. But if you took an AutoCAD class that did 3D, you would have played around with that particular system. Anyway, in Rhino, it's called a seaplane. And so in order to help see this, you can see there's my little grid that I started with. I'm going to make that a lot bigger so that we can reference this particular grid. I'll do that by going up to my tools, and I'll go into my options. And under grid here, I'm just going to change the grid line count from 200 to 2000, and I'll say OK. I'm not actually going to use it, but it helps show the orientation. So by default, this grid is set up in something called world top. That's its seaplane orientation. It's at level 0 all the way across, and it's basically regular x and y. If I change this seaplane into a different dimension, when I start to draw, it's going to draw in that plane rather than in the flat world top plane. So in order to change it, I'll go in to this little triangle next to perspective, and I'll go to Set Seaplane, and I'm going to do something called 3 points. And so when I choose 3 points, it says specify the origin of the seaplane. So in this case, I'm just going to specify something along this side. So one of these endpoints. We'll use that one. Then it says specify x-axis direction. So I'll go over here, kind of toward the right. Again, I'm making sure that I'm not snapping to anything. And there's my x-axis. Then it says seaplane orientation, or except for the default. So it wants to do it again in the flat plane. It doesn't want to go up, but I want it to go up. So I'm going to move into one of the side views until I can snap and go up vertically. So there I am in a vertical direction. And once I click in the perspective view, you should now see the seaplane vertical rather than horizontal. So when I've switched the drawing plane to be horizontal, I can now start to draw right along this line without having to change anything. I don't have to do any rotate 3Ds. So I'll go into my steps, and I'll start, say, at this step, and I'll just start drawing over. And I can use all my object snaps, and I can work my way up the side. with none of those rotate 3Ds and none of the points, because I don't need any of those for reference. So I just work my way right up the side, creating all of these little steps. So the process is essentially, I hover my mouse to use my smart tracking, I move down until I get the perpendicular snap mark, and then I move my way up. When I'm done with this whole side, right, obviously I didn't finish the whole side, but let's assume for a second that I finished my whole side. If you don't switch your seaplane back to world top and you try to go directly to one of the other sides, you're going to have trouble. So one of the rules about a seaplane to save your life so that you don't get messed up is whenever you're in doubt, go back to the original world top. And that'll undo everything and get you back to basics. So I'll immediately go back to set seaplane world top. If I can find it, there it is, world top. It essentially resets everything. Then I'll go back to set seaplane 3 points, and this time maybe I'll do it along this edge. So we'll go there, our X direction will be that way, and I want to go straight up. There it is. And we'll see the little grid moved into plane there. And so now I can start working my way back down this side, for example. Periodically, as you're doing this, it's not a bad idea to look in the side view and make sure that all of your steps are vertical. All of those steps are vertical. Look in this right side view. Yep, all of those steps are vertical. If they start to be slanted, something went wrong. Probably your seaplane was wrong. So in that case, just make sure you go back to set seaplane world top. So what I'd like for you to do over the course of today is I'd like you to get to the point where you've worked on at least 1 or 2 of the sides. If you can get all 4 of the sides done, that's great. Don't worry about the corners. If you leave the corners so that they don't quite intersect, that's okay. We're going to talk about the corners next class and how to fix them and how to look at them. The other thing that we'll do next class is I will run around with each one of you, and I'll make sure that like all of the valleys worked correctly. I'll make sure that the corners are correct so that before you move on, everything's correct. But the idea before we move on is to get the sides done. So today I want you to go through the process of taking your topography. I want you to slice it up in the scaled components. So first, trim off the excess topography to get it down to the 11 by 17 size at your chosen scale. And then go through, create all of the step lines. Once you've created that, then walk through and create the sides of this. And ultimately, we'll fold them out and do the laser cut file next class. So does that kind of make sense for what we're trying to do? Okay, question?
Is it okay to use the one that we created last class?
Sure. There's nothing wrong with using the one that you created last class. Obviously, you will then be starting with the 11 by 17 rectangle in whatever the chosen scale would be, and then trimming off the excess surface from there, and then slicing it up. So the part that we did with the topo lines and projecting it to AutoCAD and all that stuff, that's kind of irrelevant at this point because you're going to shrink it down and make it a little smaller. I will go grab one of the models so that you can, again, look at the sides and see how the steps work so that you can conceptually go through that and get ready for that as well. Are there any other questions about this? No? Okay. So give it a shot, and we'll go from there.